All right. So let's take a look at this on solving proportions. So JR reduced figure A at right to create similar figure B. Part A says write all of the ratios, not just some of them, all of the ratios that compare the corresponding sides of figure B to figure A. Now, when it says B to A, that means B is on top and A is on bottom. That's very specific. Sometimes it doesn't say. Sometimes the problem says write a ratio for this problem. It doesn't matter which one's on top and which one's on bottom. But this one says B to A, so that's going to be 3 to 4, x to 6, and 9 to 12. So if you have any of those upside down, let's get that fixed. And then it asks, what's the relationship between these ratios? They are one word. So you meant to do it the second time? All right. These are what? One word. 5 letters.
Numbers.
Equal. These ratios are all equal to one another. When you have similar figures, the ratio of the sides should all be equal. All right, so one of them could be written as 3/4 equals x over 6. There are lots and lots and lots of ways to solve this. Let's pick on somebody. Everybody's favorite. And while I'm doing this, you could be going, oh, let me get this fixed. Emma. How would you solve this?
I don't know how to do it, but I know you can cross multiply.
Well, that would be how you could do it.
But I don't know how to cross multiply.
So,
I forgot how.
so you go diagonally across the equal sign.
Like, yeah.
So 4 times x is 4x, and equals 3 times 6 is 18. Divide both sides by 4. I'm going to reduce it first. That's 9 over 2, which is 4 1/2. And the units were centimeters, so that's centimeters. You've forgotten how to cross multiply? A little bit. All right. So there are a whole bunch of different ways that you can solve a proportion. One of them is just simply reducing the fraction. So if I have this one, 18 over 24, what number divides evenly into both 18 and 24?
3.
Go bigger.
6.
6. All right. So that's equal to 3 over 4. Well, this is something over 4. So what's x equal to? 3. Sometimes it really is just that easy. This is why I keep saying over and over again, reduce the fractions. Simplify. It makes your life easier. Okay, now, that won't work all the time, but you should always reduce before you get started. So 5 over 40, what does 5 over 40 reduce to?
1 out of 8.
It's 1 out of 8. And then what can we multiply that by to get something over 24? 3 over 3. So we're just multiplying by 1. So what's x? X is 3. All right. Yes? Yes. So we'll try the same thing here, 9 over 12. Both of those are evenly divisible by 3. So that's 3 over 4. What do you have to multiply 4 by in order to get 6? 1.5. 3 times 1.5 is 4.5, exactly. So x is 4.5. So sometimes you can do it just by manipulating one of the two ratios. You can also clear the denominator by multiplication. So let's look at this one. The first thing I would do is reduce. So to clear the denominator, I could multiply both sides by 18. Two goes into 18 9 times, and 9 times 3 is 27. It has the same effect as cross multiplying, but it's all right there together. You don't have to multiply and then divide. It's all the numbers are right there together, and if you can divide easily, you do it. And if you don't, you do it later. Same idea for this one, 12 over 9. I'm going to reduce that to 4/3. With ones like this, I don't know about you, but I'm not crazy about the x being in the denominator. Right? One of the things that you can do is go, okay, what if I just took the reciprocal of both sides? Then 3/4 is equal to x over 28. That's hard to read. Try that again. So then just multiply both sides by 28. 4 goes into 28 7 times, and 7 goes into 3 21 times. By doing it this way, I didn't have to do any ugly long division. Some people always, when they get a proportion, they don't even think about it, they just start cross multiplying. But if you do that, on this one, you're going to have 12x equals whatever 9 times 28 is, and then you're going to have to do division by a 2-digit number. It's a lot easier if you don't. Okay? All right. You can also do this by fraction busting. That is, multiplying both or all the fractions by the least common denominator. So first I'm going to reduce this. 5/2 is equal to x over 7. What's the least common denominator here? 14. Seven goes into 14 twice. 2 goes into 14 7 times. I get 35 is equal to 2x. Which, by the way, is exactly what you would have gotten if you'd cross-multiplied. Divide both sides by 2, and we have x is 17.5. Ben, you look like you're thinking really hard. So, do you understand that 14 is the least common denominator? Okay, so I'm multiplying both sides by 14 over 1. As long as I do the same thing to both sides of the equation, I'm in good shape. And then I did 2 goes into 14 7 times, so I canceled those. And then 7 goes into 14 twice. And you end up with 2x is equal to 35. Okay? It's just a way to do this. Let's reduce this. 8 over 10 reduces to 4/5 equals 22 over x. The least common denominator here is 5x. I could multiply both sides by 5x. That's a little different. Over here, the 5's will cancel, and I'll get 4x is equal to, and over here the x's cancel. You get 22 times 5 is 110. Again, it's the same thing you would have gotten if you had just cross-multiplied. This is why cross-multiplication works. And I'm okay if you use cross-multiplication. Your book's not real big on it. But I get it. It works. So that's 55 over 2, which is 27 and a half. All right. So let's take a look at these. For each problem below, decide if the situation is proportional or not. If it's proportional, say so. Solve the problem using any strategy you choose. If the problem is not proportional, explain why not, and then solve the problem. All right. So Steve drove 130 miles from Portland to Tacoma in 2 hours. If he continues to drive at the same speed, how long will it take him to drive 390 miles? So remember that when you're talking about this, the easiest way to think about whether it's proportional or not is if one of the quantities doubles, does the other quantity double? In other words, if he drives 4 hours at that same rate, will he have gone 260 miles? Yeah, so this is proportional. And I like to start with what I don't know. I don't know the amount of time, so I'll call that t over 390, the time it takes to drive 390 miles. And notice I have time over the distance, so over here I should have time over the distance also. 2 over 130. So let's see, if I cross, I can reduce that. That's 1 over 65, so he's going 65 miles an hour. So 65t is going to be equal to 390. Let's see. Is that going to come out to be, yeah, it's 65, and 65 is 130. Does this go 6 times? I think it does. Oh, it goes exactly 6 times. Isn't that nice? When you give your answer, be sure to give the answer and give the correct units on it. All right, let's look at this next one. You're at an amusement park. You pay a $15 entrance fee and then $4 for each ride you go on. So, to decide whether this is proportional or not, we need to decide, well, if you do twice as many rides, do you pay twice as much money? Why not? Because what? Yeah, because of the 15, because of the entrance fee. You don't pay the entrance fee again, you only pay that once. So this is not proportional. The amount of money that you're going to pay, or the cost, You're going to pay the $15 no matter what, plus $4 for every ride. We want to know what it's going to cost you to go on 7 rides. So the cost would be 15 plus 4 times 7 is, if I did the right in my head, $43. All right, let's go on to page 3. All right, Armando has collected 39 bottle caps in the past 3 months. At this rate, how many bottle caps will he have in 5 months? So the question is this proportional? Yeah, if he saves for twice as long at this rate, he's going to have twice as many bottle caps, so it is proportional. So we want to know how many caps he's going to have in 5 months. That'll be equal to 39 over 3. It was caps over months here, so it should be caps over months here. I'm absolutely going to reduce this one because it makes it really pretty easy. It's 13 caps per month. Multiply times 5. And C is 65 caps. All right, grocery store sells 3 limes for 99 cents. At this rate, how much will a dozen limes cost? Proportional or not proportional? Everybody. Yeah, it's proportional. So I want the cost for a dozen limes. How many is that? 12. And the cost was 99 cents for 3. So the cost for 12 will be equal to 33 over 1. Because it's 33, the unit rate is 33 cents per lime. So 33 times 12, that's 66, 330, 396. So that's $3.96. There is a much faster way to solve this one than cross multiplying, though, isn't there?
Just multiply 99 times 4.
Yeah, well, we need to multiply the 3 times 4 also. Yeah, 99 over 3 times 4 over 4 is going to give us 396 over 12. Much faster than doing the cross multiplication, especially if you don't reduce. All right, but in this case, you didn't have to. All right. Margaret, who spells her name strangely, drove her friends to a movie. She drove for 30 minutes at 10 miles per hour in heavy traffic, and then drove for 15 minutes at 40 miles per hour. How far did she travel in those 45 minutes? Is this proportional or not? No, because the rate's changing, right? So how far did she travel? So the distance she traveled, T, is going to be, it's 30 minutes at 10 miles per hour. Well, we have a problem there. The rate is in miles per hour, but the time is in minutes. We need them to be the same. So 10 miles per hour times 30 minutes is how much of an hour? Times a half an hour. Plus, she drove 40 miles per hour for 15 minutes. 15 minutes is how much of an hour? A fourth of an hour. So that's 5 plus 10 is 15 miles. Questions about that?